Hey guys, so today we will continue with where we left off. We finished 3 diagrams for convex lenses. We'll finish the remaining 3 today. Okay. We'll just follow the same principle. It should not be very complicated. Okay, so since we left off at the 4th one, I will start at diagram number 4. Okay. Now the diagram number 4 is again, like I said, for every step you take the object forward a little bit, right? So where we stopped, the object is at C. So now we just make sure that the object is a little forward from C, which is between C and F, right? So object between C and F, right? So there goes the diagram. F2C2, F1, and I'll repeat it again. Make sure distancing is equal. Okay, your diagram won't be accurate. Like I said, object between C and F means it should stand about here, right? Now this object goes forward as the image. Where is the image going to form? Okay. Now, not surprisingly, I'm going to use the same two rules then. Okay. First rule is parallel line. Okay, and every parallel line goes through focus. And the next one is going to be through the optic center. I try to make it as straight as possible. Okay. Now if you see, they have made somewhere here. So now if I draw the image, it's going to look like this. Look at the size of the object, look at the size of the image. Big difference, right? So whenever an object is between C and F, what happens is the object is magnified, right? It's enlarged. Basically, it looks bigger than it is. So I'll say that it is an enlarged image. Okay, it is still real and it is still inverted, right? Inverted images are generally real, right? And keep note, this side object, that side image. Alright. This is the 4th case. Now, time to bring this object one step forward more. We'll put it at F, right, which is at the focus. So, if I go with that, number 5, object at focus. Okay. Now, again the same diagram. Now, we said object has to be at the focus, which is here. same two rules. First the parallel line, okay, which means it goes through focus like that. The second one goes to the optic center straight. And admit, are these lines looking like they'll meet anywhere? No, right? They're nearly parallel, almost, but they're not perfectly parallel. Means they'll meet at some point. But if you see, my board is not big enough, neither is my wall. If I extend it, I'll still not be able to reach where these two lines meet, right? So this case is called image being at infinity, okay? Now, it's exactly opposite to the first case we saw. Object infinity, image focus. Object focus, image infinity. Switch. So that would mean that if an object is infinity, it means it's really large, right? So if it just behind C is so big, imagine if it's much more further, how large the object will be. So we call it highly enlarged. Okay. It's a highly enlarged image in general. And as to whether it's real and inverted, yes, it will be. Okay, because it's coming on the other side of the lens. So I will still call it real and inverted image. Now, coming to the last case in point, which is nothing but one step further between F and O, right? O is nothing but optic center, which is this point over here. Alright? Now, if I have to draw this diagram, what would it look like? First, the axis, and this, 2, C2, F1, C1. Now, if I put an object here, where will it go? Again, the same two rules. First one goes through focus like that, right? Second one goes through the optic center like now. Do you think these two lines are going to meet anywhere? Like all these lines, if you see, they are coming closer, so you can tell they meet. But these lines, if you see, they are going farther from each other, right? So these lines will never meet. So where is the image going to be formed? For that, we need to do what we call as tracing back. Alright, so you take the reflected ray and you kind of start drawing dots back in the same direction. See what I did there? Drawing back. Keep it more accurate. Kind of like that. It's hard to do without a scale. Please make sure you use the scale. Right? Do the same for this side also. Right? So, if you notice, the points meet here means this is the arrowhead. Right? Now, what does this tell me? The object image are formed on the same side of the mirror, but this image is upright, it's not upside down like this image. Right? So definitely this is not a real image, it's called a virtual image and it is standing straight up, so it's called an erect image also. Now this case is the only case for all of for this mirror, right? In convex, the only time you get a diagram like this if you put it over here. Same with the mirror also. If you remember the concave mirror diagrams, same case, right? You trace the lines back and you get the image, which is virtual and erect. So over here, I will say that image is definitely bigger than the object. So I will still say it is magnified, okay, or enlarged. You can use either one, because it's still bigger than the object. Okay, so these are the 6 rules that you follow. Ray diagrams are quite important. They come from time to time as a lot of marks. So do make sure you're practicing all of these diagrams. One thing to keep in mind is use a pencil scale always. Do not use a pen to draw these diagrams. It will get really messy. And never forget the arrow marks. Okay, you forget the arrow marks, it's as good as gone. Right? You will not get marks for that question. Okay, so please make sure you put the arrow marks wherever they're supposed to be. About it, these are all the diagrams for convex lenses, and honestly these are used in most of the places that we see. For example, telescopes or magnifying glass, microscopes, because of this, that you see, this is something called as a magnifying effect, that it shows an object as large for any of these cases really. So what we try to do is, if there's a really small object you want to see it large, you use a convex lens. The stronger the lens, the bigger you will be able to see that object as, right? So a major use for lens, this lens also we have learned today. Okay, so tomorrow we'll carry on with the remaining part of this chapter. For today, this is all.